Hi, Stephen Krivit here from New Energy Times. Thanks for joining me today. This is a six-part series about the conference presentation I gave on the Widom-Larsen theory in 2023 in Poland. This is part 6. The obvious question for anyone who's not followed the field closely is that if the Widom-Larsen theory is so successful, then why doesn't the LENR research community seem more supportive? The primary reason is that the Widom-Larsen theory does not explain LENRs as cold fusion. This runs counter to the way a lot of the researchers in the field have been thinking for 3 decades. In March 2010, 2 U.S. Department of Defense contractors, Edward Toten and George Ulrich, gave a presentation focusing on the potential value of the Widom-Larsen theory. In their conclusion, Toten and Ulrich listed, among others, 3 insightful bullet points. In the first of these, they reminded their audience of the potential humanitarian value of LENR research. It's now 13 years later. There still appears to be little visible interest in the Widom-Larsen theory, but a shift has occurred. I saw it and heard it with my own eyes and ears at the ICCF25 conference. I need to give a little background first. Textbook nuclear fusion tells us that when deuterium nuclei fuse together, 3 sets of reactions will take place. These are also known as the fusion branching ratios. In the first branch, helium-3 and a neutron will be produced. In the second branch, a triton and a proton will be produced. Fusion reactions will occur in these 2 branches with equal probability, almost 50% of the time each. However, the third branch is very rare. This is when a deuterium-deuterium fusion reaction produces helium-4 along with a gamma ray. It takes place less than 1% of the time. That's why Fleischmann and Pons, in their April 1989 paper, and only that first paper, proposed just the first 2 reaction branches. Most LENR researchers don't realize that Fleischmann and Pons never proposed the third branch reaction. Instead, it was Hagelstein who first proposed the third branch. So rather than following Fleischmann and Pons, LENR researchers who believe in the cold fusion idea are actually following Hagelstein, who went back to a fusion hypothesis after he gave up on his neutron hypothesis. In a paper that Fleischmann and Pons presented in October 1989, they didn't propose any deuterium-deuterium fusion reaction. And as I've shown in my presentation, by 1994, Fleischmann and Pons emphatically stated that the simplistic Hagelstein equation from 1989 could not possibly explain the experimental results. 2 decades later, I spoke with Fleischmann about this. He said it was a mistake for he and Pons to claim that their results were caused by a fusion reaction.
Fusion has a special meaning in the scientific literature, hot fusion. And perhaps it was a mistake to call this process fusion. It should have been called a nuclear effect.
As I explained in 2008 at the American Chemical Society meeting, there are 8 reasons why the experimental results in LENRs are inconsistent with the results of deuterium fusion. Electrochemist Michael Makubre knew a lot of these reasons in 1996.
Unquestionably, there's a source of excess heat in these experiments, where these experiments are heavy water palladium experiments, the only ones that I have looked at. There is a source of excess heat that we can't account for.
Now, that doesn't mean that it's cold fusion as we traditionally think of it. It might be something that we can't begin to understand at this point. Is that right?
Oh, I think so. I think the name is unfortunate. Cold fusion was coined by physicist Steve Jones at the outset when he thought he saw neutrons coming out of his experiments. I think whatever is happening is not likely to be deuterium fusion in the heavy water cells, and if Patterson is right, and I'm not certain that he is, but I believe that he might be, if he is right, then he is clearly not observing fusion.
However, by the time I started reporting on the field in 2000, Makubre had changed his mind, not to mention his data. By then, he and LENR researcher Edmund Storms were saying that helium and excess heat are not produced in LENR experiments when normal hydrogen is used. I remember meeting George Miley and asking him about his light water LENR research. The smile on his face immediately vanished. He said, "I don't talk about that anymore," and he quickly walked away from me. In 1998, Dave Nagel wrote that the dismissive reaction from the people working with heavy hydrogen to people like Miley working with light hydrogen was not much different from the dismissive responses in 1989 from the broader scientific community to all of the researchers who were working on LENRs at the time. Why was there such hostility and incredulity toward the results of these researchers working with light hydrogen? It's simple. If deuterium was not used as a reactant, the mechanism could not possibly be explained by any kind of deuterium-deuterium cold fusion theory. But in 2023, at the ICCF25 conference, to my amazement, there were more LENR researchers reporting the production of excess heat with light hydrogen than with heavy hydrogen. They're using nickel instead of expensive palladium, and not one person during the meeting attempted to discredit the normal hydrogen results. It's taken some time, but times have changed. The other interesting thing I noticed at ICCF25 was that several researchers reported anomalous heat, not just when hydrogen gas was absorbed into the host material, but even more so on the desorption cycle. And if we go back and look at the history from 1989, just 1 month after Fleischmann and Pons announced their claim, we find that yet again, the evidence was already there 34 years ago, but dismissed.
Dick Beatty, Kent State. I'll address my question to Steve Koonin. Can you comment on the results that the Italians reported where they saw neutrons 10 times above background on the adsorption cycle and 100 times above the background when they desorbed for gas adsorbed on titanium shavings?
I think there are two reported experiments, the original experiment from Frascati, for which the preprint is floating around, and there is the report of a confirmation from Genoa, in which we have extremely sketchy results. The basic experiment is to put deuterium over titanium shavings or powder, pump it up to 10 or 50 atmospheres, drop it down in temperature to liquid nitrogen, and then let it warm up. The claim is that you see bursts of neutrons coming out when the system goes through one of the phase transitions in the titanium hydrogen system. I have a graph here which I can show you privately if you like. It doesn't tell us very much. I think, as in all papers, one wants to see this in a little more detail and think about it before making a conclusion one way or the other. That's, of course, part of the problem with the recent history in this business.
The deuterium-deuterium cold fusion concept cannot explain the production of heat and helium in light hydrogen experiments. The Widom-Larsen theory can. Experimentalists in the field who have now accepted light hydrogen LENR results may not have done so as a result of the Widom-Larsen theory. They may have simply followed the science. Either way, the majority of researchers presenting experimental LENR results now are making more scientific choices about their approaches. They're heading in the direction described and explained by the Widom-Larsen theory. I'd like to thank Konrad Chersky for allowing me to give my presentation at the conference. I'm grateful to Alan Widom and Louis Larsen for taking the time to speak with me at length about their theory. And as always, I am super grateful for the awesome team at New Energy Times. Thanks for watching.